In this video, we're going to investigate patterns of association of bivariate data in scatter plots and frequency tables. First, let's talk about what a scatter plot is. A scatter plot is a graph that shows the relationship between two sets of data. The two sets of data are graphed using ordered pairs. We also need to know what bivariate data means. Bivariate data has two variables. When we graph bivariate data, we can see if we have linear association. This is if they show a linear relationship. And then finally, we can use something called goodness of fit. This is really the line of best fit. It can be used to write an equation in order to make predictions. Let's talk about some scatter plot relationships. The first is a positive linear relationship. What this means is as one variable increases, the other also increases. An example of this is the longer you exercise, the more calories you burn. The amount of calories burned increases as the time spent exercising increases. The next kind of relationship is a negative linear relationship. As one variable increases, the other one decreases. An example would be the more you pay on a bill, the lower the balance will be. Next is a nonlinear relationship. What that means is that there is a relationship, but it's not linear. Graphing cubic relationships would be an example of a nonlinear relationship. And then there are scatter plots that show no relationship. An example would be the amount of money in your bank account and how many hours you slept that night. Pause the video and decide whether the following have a positive linear relationship, a negative linear relationship, or no relationship. Now let's see how you did. The first one says the temperature outside and the air conditioning bill. I like to use arrows to help me choose what kind of relationship they have. As temperature goes up, so is the air conditioning bill. So we have a positive linear relationship. The next one says shoe size and age. As your age increases, your shoe size is also probably going to increase. So this one is also positive linear. The third one says the ink in your pen and the words written. Well, the more you write, the less ink is going to be in your pen. So because these go in different directions, you're going to have a negative linear relationship. And the final one says your hair length and your IQ. This one is no relationship. You can have long hair and have a high IQ, or you can have short hair and have a high IQ. The following table shows ice cream sales given the temperature outside. Let's graph the following data and then find the line of best fit. The first step is to label your graph. I put temperature on the x-axis and I counted by 2s. Then I put sales on the y-axis and I counted by 50s. After your graph is labeled, you need to plot the points. Now that we have the points plotted, we can see that we have a positive linear relationship. As temperature increases, our sales go up. Now we need to create the line of best fit. When doing this by hand, you're just going to try to get in the middle of all the points. Your goal is to estimate a straight line that goes through the majority and the center of the points. And now we have the line of best fit. Once you have your line of best fit, you can write an equation. This equation can be used to make predictions.